Now we discuss what is the general expression for power consumption in an AC circuit. What we studied earlier is the specific case, power consumption in resistor, inductor and capacitor. Now what is the general formula? So power dissipated in an AC circuit, in general voltage is taken as V naught sin omega t, current is given as I naught sin omega t plus or minus phi. What is phi? Phase difference between current and voltage. Phase difference between V and I. For example, in the case of resistor, what is the value of phi? Phi is 0 degree because current and voltage are in phase. But in the case of inductor or capacitor, it is 90 degree. So, it is the general formula for voltage and current. Now, for the derivation, either you have to take here positive sign or negative sign. To make it convenient, we take positive sign. Therefore, it is sin omega t plus phi. Average power consumption, P average equal to, it is integration of instantaneous power over the complete cycle divided by T, which is equal to, it is integration 0 to T. What is the instantaneous power? V into I dt by T. Now we substitute P average equal to, it is integration 0 to T V naught sin omega t into current I naught sin omega t plus phi into dt divided by T. P average, take V naught outside, I naught outside because they are the constant values, divided by T, then integration 0 to T, it is a sin omega t. Expand this one using sin A plus B formula. Sin A plus B is nothing but sin A cos B plus cos A sin B. Therefore, we expand this one, it is a sin omega t into cos pi plus cos omega t into sin phi dt. P average equal to V naught I naught by T you take sin omega t inside the bracket. So, it is integration 0 to T bracket sin square omega t cos phi plus sin omega t cos omega t into sin phi dt. P average V naught I naught by T. Now you integrate this one separately, that part separately. Therefore, it is integration 0 to T, it is sin square omega t cos pi dt plus integration 0 to T, it is nothing but sin theta into cos theta. I already said it is sin 2 omega t by 2 into sin phi dt. P average equal to V naught I naught by T square bracket. Here cos pi is a constant, it is cosine of the phase difference between current and voltage, it is a constant value, take it outside, cos phi, then it is 0 to T sin square omega t dt plus, here sin pi is a constant and 2 is a constant, take them outside, sin phi by 2, it is integration 0 to T sin 2 omega t dt. P average is equal to, now V naught I naught bracket, take T inside. So, it is cos pi first term constant, it is nothing but average value of sin square function over the complete cycle. So, how to write it? It is the average value of sin square omega t over the complete cycle plus sin pi by 2, take T to here, it is the average value of sin 2 omega t over the complete cycle. Now, P average is equal to, this is V naught I naught and what is this, cos phi, and the average value of sin square function already we know it is half plus average value of sin function over the complete cycle, this is 0, therefore, second term is 0. Therefore, P average equal to, it is V naught I naught by 2 into cos pi. This can be written as V naught by root 2 into I naught by root 2 into cos pi. What is this V naught by root 2? VRMS, I naught by root 2, IRMS into cos pi. Therefore, average power consumption P average is equal to VRMS IRMS into cos pi. This is the formula for average power consumption when AC flows through any circuit. VRMS into IRMS is also known as apparent power consumption. So, P average equal to P apparent into cos phi, where P apparent equal to V RMS into I RMS. Very important one. Look at this term cos phi. Cos phi is known as power factor of the AC circuit. The term cos phi is known as power factor of the AC circuit. Cos phi, it is known as power factor of the AC circuit. Why this term cos phi is known as power factor of the circuit? The reason is this cos phi that actually decides what is the power consumption in the AC circuit. Moreover, VRMS and IRMS is known as apparent power. Why this is known as apparent power? For that, we have to compare this equation with DC circuit. What is the meaning of that? If you take any DC circuit, If you take a DC circuit and you want to calculate power consumption, we take one simple circuit, DC circuit. Let us say it is the resistance R connected to the cell, so that current flows here, and here you have got a potential difference. Now we know power consumed in DC circuit, we can write P DC, or simply P is nothing but voltage across the resistor multiplied by current, V into I. But if you want to do this experimentally, you are asked to do the experiment, then what is this V? V means voltage across the resistor. How to measure voltage across the resistor? By connecting one voltmeter. Therefore, here across the resistor we connect one voltmeter. So, here V means it is the voltmeter reading. Similarly, how to measure current? Current can be measured by connecting one ammeter. So, in the case of DC circuit, power consumption means it is the product of voltmeter reading and ammeter reading. In generally, it is the voltmeter reading across the circuit divided by ammeter reading, which measures the current in the circuit. Now, you take the same idea to the AC circuit. In AC also, meters are ammeter or voltmeter. Generally, they are designed to indicate RMS value. I said RMS value is the general value of AC. Okay? So, for example, if you go and purchase one ammeter, AC ammeter or AC voltmeter, then it is designed to indicate RMS value. So, now we take some AC circuit, like this is some AC circuit. It contains different components. I am not saying that it is resistor, it has got different components, some complicated circuit, which is now connected to AC source. And I am applying the same logic here. I want to find out what is the power consumption here, average power consumption. Average power consumption means it is the voltmeter reading multiplied by ammeter reading. We are taking this idea to here. Therefore, to measure voltage, here we connect AC voltmeter, which indicates V RMS. Voltmeter reading is nothing but V RMS, and I want to measure current in the circuit. What is that current? I RMS. For that, we connect AC ammeter. So, you know how to calculate power consumption, how to experimentally calculate power consumption in DC circuit. Same idea is taken to AC circuit. Therefore, this voltmeter shows VRMS and this ammeter shows IRMS. You multiply both of them, VRMS into IRMS. But the question is it becomes actual power consumption? No. If it is multiplied by one more term, what is that term? Cos pi, then only it is the true power consumption or actual power consumption. Therefore, now it is multiplied by cos pi, then only it is P average. Therefore, in the case of AC circuit, actual power consumption over the complete cycle is given by voltmeter reading multiplied by ammeter reading, let us say multiplied by cos pi. But if it is the DC, power consumption is decided by voltmeter reading and ammeter reading, like this, over. But here you have got a one more term, that is cos pi. And why this is known as power factor of the circuit? Okay. Now, voltmeter reading multiplied by ammeter reading, is it becomes power? No. If it is the DC, voltmeter reading multiplied by ammeter reading becomes power, but not here. Therefore, VRMS and IRMS is known as apparent power. This is taken as what? Apparent power consumption. Now, who is deciding the actual power consumption? It is not voltmeter reading or ammeter reading, it is caused by. For example, think that you are doing some experiment here and ammeter reading is 100 volts and voltmeter reading is 100 volts and ammeter reading is 10 ampere. Think like that. Voltmeter reading is 100 volts, ammeter reading is 10 ampere, and what we think, there is a lot of power consumption because voltmeter reading is high, ammeter reading is high. Power consumption, what we expect, power consumption is also high, but your idea may be correct or wrong. The reason is, if phase difference is 90 degree, think that phase difference is 90 degree, cos 90, then what is the answer? Answer becomes 0. Therefore, in the case of AC circuit, actual power consumption is not decided by RMS reading, it is decided by cos pi, where phi is the phase difference between current and voltage. Therefore, the actual power consumption mainly depends upon cos pi, not by voltmeter reading nor by ammeter reading. Hence, it is known as power deciding factor or power factor of the AC circuit. This average power consumption is always in watt. So, the SI unit of P average is watt, that already you know, SI unit. And here you have got one more term, P apparent, it is Vrms into Irms, but it is not the actual power, therefore, do not express this one in watt. So, P apparent is expressed in, not in watt, it is Vrms and Irms, Vrms is in volt, Irms is in ampere. Therefore, the SI unit of apparent power is volt ampere, it is not in watt. This is a one mark question for board exam as well as for CET. What is the SI unit of apparent power? Or apparent power is expressed in terms of watt, volt ampere, like that you can expect. So, what is the unit you have to write? Volt ampere, do not write watt. Now, we consider cos pi, it is the cosine of the phase difference between current and voltage known as power factor. So, power factor is equal to cos pi, which is also equal to, what is the cos pi? Average power by apparent power, P average by P apparent. Therefore, how to define power factor of the circuit? Power factor of the circuit is defined as cosine of the phase difference between current and voltage. It is the correct definition. Or one more definition, power factor of the AC circuit is defined as the ratio of average power consumption to apparent power consumption. This also you can write. Okay. Now, if you take resistor circuit, inductor and capacitor, then we know what is the phase difference between current and voltage, and we can simplify this formula in the case of resistor, capacitor and inductor. So, for resistor circuit, phi is 0 degree, means current and voltage are in phase. Therefore, what is the power factor? Power factor is equal to cos of 0 degree, that is 1. So, for resistor circuit, power factor is always 1. What about inductor and capacitor? For inductor and capacitor, phase difference is 90 degree. So, for L and C, phi equal to 90 degree or pi by 2 radians. In that case, power factor is equal to cos 90 degree is equal to 0. So, this you can expect for 1 mark in annual exam. What is the power factor of the resistor circuit? Power factor of the resistor circuit is 1, do not write 0 degree. What is the power factor of inductor circuit or capacitor circuit? Power factor of the inductor capacitor or capacitor circuit is 0. Now, average power consumed in a resistor circuit. In the case of resistor circuit, P average is equal to V RMS I RMS into cos pi. But for resistor circuit, what is the cos pi? 1. Therefore, it is 1, that is V RMS into I RMS. Therefore, if it is a resistor, it consumes energy both in DC and AC circuit. Okay? And already in the first discussion for power consumption, we got the same formula in the case of resistor circuit. Now, we take L and C. L and C. What is the average power consumption? Average power consumption is equal to V RMS into I RMS into what is the power factor? Power factor is 0. Therefore, it is 0. Answer is 0. Hence, if it is a pure inductor or pure capacitor, then in the AC circuit they never consume any energy. Okay. Now, next one is we discuss series LCR circuit, means all the 3 components resistor, capacitor, inductor are in series. So, series LCR circuit, series LCR circuit. Here L stands for inductor, C for capacitor, R for resistance, and all 3 must be in series, but any one of them may be in the first, another component may be at the last, like that. It need not be inductor first, capacitor must be the second one, resistor must be the third one. No, it is not like that. All 3 components must be in series, known as the LCR circuit. The circuit drawing is like this. It is a resistor connected to the inductor, and then it is connected to the capacitor like this. Okay. It is resistor R, inductor L, capacitor C. It is connected to AC source, and now we derive the equation for current through the circuit, and even we derive the equation for total opposition of this circuit, like that. Now, first of all, we try to draw the phasor diagram for this circuit. How to draw the phasor diagram for the circuit? Now, we know phasor drawing is always for peak value of the voltage and current. All of them are in series, therefore, through all of them current must be same. So, think that I naught is the peak current through the circuit. I naught is the peak current through the circuit. Do not put arrow mark. Arrow mark means you are losing 1 mark. That represents, that becomes DC, but it is AC. Think that I naught is the peak current, because I want to draw phasor diagram. That current I naught passes through resistor, the same current flows through inductor, and the same current passes through capacitor also. Whenever this current flows through the circuit, we have got a potential differences across the three components. Let us say VR is the voltage across resistor, but it is which voltage? It is the peak voltage across the resistor. It is not RMS value. It is the peak value of the voltage corresponding to peak current. Let it be VR, and here it is VL, and here it is VC. VR, VL, VC are the peak voltages across resistor, inductor, capacitor for the current I naught. Now, we write the equation for that. It is VR, voltage across resistor, is equal to I naught into R. What about voltage and current? Are they not in phase? Definitely they are in phase. Therefore, we can write VR and I naught are in phase. Voltage across inductor VL is equal to I naught into XL. It is not L. Most of the students they write L here. That is wrong. It is I naught into XL. What is XL? Inductive reactance. Okay. Then what is the relationship between voltage across inductor and current? They are not in phase, they are out of phase. What is the phase difference? 90 degree, and in this case voltage leads the current by 90 degree. Therefore, VL leads I naught by 90 degree or pi by 2 radians. Capacitor VC, peak voltage across the capacitor is equal to I naught into XC. Do not write C, it is XC, capacitive reactance. Again, voltage across capacitor and current through the capacitor are out of phase, phase difference is 90 degree, and who is leading? Current. Therefore, I naught leads VC by 90 degree or pi by 2 radians. Now, we try to draw the phasor diagram for these three peak values. They are all, these three are peak values. So, now we can draw phasor diagram. Now, look here, through all of them current is same. So, you take resistor. In the case of resistor, think that it is representing current in phasor drawing. It is not the direction. I am just marking current as in the case of phasor drawing. Let us say it is I naught. Do not say it is direction. No, I naught is the phasor diagram. And what about VR? VR is in the same direction. And if you take inductor, current will be same, I naught. Again, I am telling that it is not representing direction, it is the phasor drawing I naught. And what about voltage? Voltage is leading by 90 degree. VL leads I naught by how much? 90 degree. Therefore, this is VL, voltage across inductor. And here for the capacitor it is I naught. And in the case of capacitor, current leads the voltage by 90 degree. Therefore, this is voltage VC. So, these are the phasor diagrams for the respective components. It is the phasor drawing for resistor, it is the phasor drawing for inductor, phasor diagram for capacitor. Now, we can superimpose all of them. How to superimpose all of them? In all of them current will be same, no. Therefore, you superimpose so that the I naught, that particular vector coincides. Then we get the phasor diagram for LCR circuit. So, now we draw phasor diagram like this. See here, this is I naught. I naught this. And what about VR? VR is the peak voltage across resistor. It is in the same direction. Voltage and current are in phase. Let us say it is origin, it is point A. Now, for inductor, current is here I naught. What about voltage? 90 degree ahead. Therefore, I naught will be the same and voltage is taken in this direction 90 degree ahead. This is voltage across inductor, let us say it is OB. So, 90 degree with respect to current 90 degree ahead. Vc is equal to I naught Xc, where current leads the voltage by 90 degree, means current is leading, voltage is lagging, lagging means down by 90 degree. So, this is here Vc. Let us say OC. Therefore, OA represents peak voltage across resistor, OB represents peak voltage across inductor, OC represents peak voltage across capacitor. Now, if you add all the three voltages by vector method, that is the voltage across the combination. Think that if it is a DC circuit, in the case of DC circuit, voltage across the combination is equal to V1 plus V2. You already know this one, resistors in series in DC circuit. And here we can add all the three voltages, not directly because they are taken as a vectors, they are represented in phasor drawing. Therefore, we have to add them by vector method. If you add them by vector method, then it is the peak voltage across the combination. Therefore, we can write like this. Think that V naught is the peak voltage across the combination, V naught, and we know V naught, vector V naught is equal to, it is vector VR plus vector VL plus vector Vc. Even though voltage is a scalar quantity, here they are taken as vectors, rotating vectors. Now, if you add them by vector method, it is V naught. So, now I want to solve this part first. VL and Vc I want to find out in the first step, because they are in opposite direction. See, VL is in one direction, Vc is in the opposite direction. How to find out the resultant? We know if there are two vectors in opposite direction, resultant is always equal to difference, and it is in the direction of larger vector. So, think that VL is more than Vc. So, I will erase this one. So, take VL greater than Vc. For example, let us say it is 10 volts and Vc is 4 volts. Think like that. Voltage across inductor is 10 volts, voltage across capacitor is 4 volts. What is the difference? 6 volts. What is the direction of that 6 volts? In this direction, because already we are taking this as a higher value. So, 6 volts here you have to mark. So, take VL greater than Vc, then the resultant of VL and Vc represented by one more vector like this. Let us say it is OD, which represents VL minus Vc. So, then OD represents VL minus VC, actually vector. Okay. So, we got resultant of 2. This vector and VR, again we try to find out their resultant. So, how to find out their resultant? It is by completing parallelogram. If you complete parallelogram, then a diagonal gives resultant. So, it is resultant of VR, VL and VC, it is nothing but V naught. Let us say it is the point E. Therefore, OE represents sum of all the 3 vectors. Okay. OAE is the right angle triangle. OAE is the right angle triangle. So, now take that right angle triangle. So, in the right angled triangle, OAE, OE square according to Pythagoras theorem, OE square is equal to OA square plus AE square. What is OE square? It is V naught square, where V naught is the peak voltage across the circuit, is equal to OA square. What is OA? Representing peak voltage across resistor, VR square. And what is AE? AE is also equal to OD, parallel side of the rectangle. But OD, is it not VL minus VC? Therefore, it is VL minus VC whole square. So, V naught square is equal to, according to Ohm's law, VR is equal to I naught into R square, I naught square into R square plus VL. What is VL? I naught into XL, I naught into XL minus I naught into XC whole square. Now, V naught square is equal to, we can take I naught as a common term outside. Therefore, it is I naught square, and what are the remaining terms? R square plus XL minus XC whole square, or V naught square is equal to, it is okay, I take square root. So, V naught is equal to, it is I naught into square root of R square plus XL minus XC whole square. Now, you can compare this formula with Ohm's law. So, what is the meaning of that? You know V equal to what? IR. So, just to compare, this is voltage, here also it is a peak voltage, it is current I, here also it is current I, here it is resistance of the circuit. In that position, you have got a square root of R square plus XL minus whole square. Therefore, the term inside the square root must be equivalent to what? Resistance of the LCR circuit. But if you say the term inside the square root is the resistance of the LCR circuit, we have got a problem, because this is what? Reactance. Is it a resistance? No, it is reactance. Therefore, it is not resistance. Can we say this term as a reactance? then also it is not possible because it is resistance. Therefore, it is this particular term inside the square root, it contains resistance part and reactance part. It is known as the total opposition of the LCR circuit for the flow of AC. It is now known as impedance of the circuit, and impedance of the circuit, its symbol is Z. Therefore, now we can rewrite the formula V naught is equal to I naught into Z. And what is Z now? Z is equal to, it is the square root of R square plus XL minus XC whole square. So, I will write it here. Z is equal to square root of R square plus XL minus XC whole square, known as impedance of the circuit. Impedance of the circuit. So, this derivation you can expect for 5 marks in annual exam. Derive the expression for impedance of the LCR circuit. Okay. Now, whenever we say impedance, remember that it is the total opposition offered by the circuit for the flow of AC, and it contains both reactance part and resistance part, both together. Okay. Now, we continue this derivation discussion. Look here, it is very clear now. If you look into this phasor drawing, it is the peak voltage across the circuit V naught. It is the current through the circuit, peak current I naught. Definitely, voltage has got a higher phase angle compared to current. Therefore, who is leading? Voltage is leading the current. So, voltage leads the current, and we have got a phase difference between voltage across the circuit and current. That phase difference is taken as phi. So, this angle now we take it as phi. Phi is the phase difference between peak voltage across the circuit, LCR circuit, to the peak current through the circuit. And again you take this right angle triangle OAE. In this right angle triangle, what is the tan phi? Tan phi is equal to opposite side. What is the opposite side? AE divided by adjacent side OA. But AE is also equal to OD. What is OD? VL minus VC divided by OA. OA represents VR, peak voltage across resistor, or tan phi is equal to voltage across inductor can be written as I naught into XL minus I naught into XC divided by I naught into R. I naught is a common term, we can take it outside and we can simplify it. Then it is XL minus XC by R. I naught we can cancel as a common term. Therefore, now phi is equal to tan inverse of XL minus XC by R. This is the expression for phase difference between current and voltage. And who is leading? Voltage is leading the current. Now, what is the equation for voltage and current? Generally, what is the formula? For voltage, equation is standard. V is equal to V naught sin omega t, where omega t is this angle. It is V naught, therefore, it is omega t. This full angle is omega t, that is this formula. And current I is equal to I naught sin, what is the phase angle for current from here to here omega t, anti-clockwise omega t, then clockwise phi, because this is the phase angle for current, and we know this angle is equal to omega t minus phi, omega t minus phi. Therefore, I is equal to I naught sin omega t minus phi. This is the formula for current and voltage, where phi is given by tan inverse of XL minus XC by R in this case. Okay. So, now see here, we know when in the phasor drawing, if you take y component, that represents instantaneous value, and in the exam no need of marking instantaneous value. This diagram is enough for the exam, or even we will go for next simple diagram, one more simple diagram that I will explain later. So, if you want to mark instantaneous value, this is V naught, we take its y component, that is this. Look here, this represents instantaneous value V. V is equal to V naught into sin omega t. And what about current? This is I naught. So, we take its y component. So, this is I, instantaneous current. This is I naught. I will write it here, I naught. So, it is the instantaneous current. What is the formula for instantaneous current? I naught into sin omega t minus phi. It is the phase angle for current, that is this. Okay. Now, we know how to calculate power factor of the circuit, because if you want to calculate average power consumption, it is V RMS, RMS voltage across the circuit, into I RMS current, RMS current through the circuit, into cos phi, where phi is the phase difference between current and voltage. So, now we try to find out power factor of the circuit from this phasor diagram. Okay. Now, cos phi, you look at the triangle OAE. In this triangle, this angle is phi, and what is cos phi? Cos phi means it is adjacent side by hypotenuse. So, in this right angle triangle, cos pi means adjacent side. What is adjacent side? VR by hypotenuse. What is hypotenuse? V naught. VR can be written as I naught into R divided by V naught is nothing but I naught into Z. Already we got this equation in the earlier discussion, and I naught we can cancel, it is R by Z. Therefore, if you take any circuit in general, power factor of the AC circuit is given by the formula R by Z, where R is the resistance of that circuit divided by Z impedance of that circuit. This is very important formula for the competitive exam, or even to solve some problems in board exam. Okay. Now, see, I said in the earlier, we go for some simple drawing instead of this. Even simple drawing is enough for annual exam, because for many students it is very difficult to draw. They make lot of mistakes in this diagram. So, what is the simple drawing? Look here, you do one thing. This is I naught and this is peak voltage across resistor. You take both of them to x axis, you bring back them to x axis, means OA is coinciding with x axis. When OA coincides with the x axis, what about OB? It is along positive y axis. And what about OC? It is along negative y axis. Then we get very simple phasor diagram. This is I naught, it is voltage across resistor, peak voltage. This is VL and VC is less. Now, we consider for derivation purpose, we consider VL greater than VC, that is what I said. Think that it is a 10 volt and it is 4 volts. What is the difference? 6 volts. So, 6 volt may be here somewhere. OD, it is representing VL minus VC. So, complete the parallelogram. It is the resultant of VR, VL and VC. Then this diagonal represents resultant of all the 3 peak values, that is V naught. So, for exam you draw this diagram, it is enough for 5 marks derivation, and it is I naught, it is V naught, angle between them is phi, phase difference between current and voltage.